So I'm going to be talking about the fact that I never ever want to run an EC2 instance ever again. If I have to do that manually ever, I'm doing it wrong. So, so, ah, if you're wondering, I am part of a team at VMware called Cloud Journey, and we have a nice website called cloudjourney.io. That man over there is wearing a shirt that has the URL on there too. So, if you want to take a picture, this is probably the slide that you want to check out. Simply because it has our Twitter handle, it has the URL to it, and we actually publish a fair amount of content that we talk about, including what I'm going to be talking about right now on that website. So if you're wondering who I am, my name is Stigter. I'm a developer advocate at VMware. I am passionate about things like serverless, containers, and generally all things cloud. So for me to join VMware might sound a little weird because everyone thinks about VMware as like, the VM company. And while that is absolutely true, we definitely do VMs. We do a lot more than that. We actually have a lot of stuff in public cloud. We actually have a lot of stuff that works on things like containers, that works with serverless. And I love dad jokes, cheesecake, and go. So if you ever need to bribe me, cheesecake is going to be your best bet. So are we really going to be talking about containers? And as I was preparing for this presentation, I found this amazing image by Forrest Brazil, if I pronounce his name correctly. If I don't, then I do apologize, which kind of sets the tone about people talking about containers, people talking about serverless. I mean, when you talk about serverless, a lot of people are going to say, in that case, you can never do containers. When you talk about containers, people are saying, well, in that case, you can never do serverless. And the thing is, to me, I actually think you can definitely do both together. To me, a container is nothing more than a packaging format, like a zip file used to be, or a tar file, or whatever your choice of packaging. And they can absolutely be serverless. I mean, AWS, and we're going to be talking about that, actually has a great solution for running containers in a serverless way. So at our GitHub page, we actually have an entire application that we created that runs on Kubernetes, that runs on Docker Compose. And as we were thinking about what can we do to make sure that a lot more people can play around with this, one of the things was, which I suggested, let's move it to Fargate. Let's see what it's going to cost, and we'll cover that at the end, to run our fitness app, our Acme Fitness Shop, on Fargate as opposed to running it on Kubernetes. So, by the way, before we get into that, who thinks it costs more to run it on Fargate than it does on Kubernetes? So hands for Fargate is more expensive. Hands for Kubernetes is more expensive? Okay, good. I do like that breakdown. So the things that we're going to be creating, because this is pretty much the last slide that I'm going to be talking about, is we're going to be creating log groups. We're going to use Amazon ECS, or Elastic Container Service, where we're going to create a cluster. We're going to create a bunch of task definitions, because that is what Fargate uses. We're going to create a bunch of services. So that is pretty much in line with what you would do in Kubernetes. Now, Kubernetes has its own DNS service built in, and instead we're going to be using AWS Cloud Map, which is actually a really nice service. We're obviously going to be using a bunch of IAM roles because everything has to be tied down, which is also why we're using EC2 security groups, so that we can make sure that the only traffic going into a container is really only the traffic that should be going into it. So let's actually go do that. So I'm going to end the slideshow here for a second, go over to my VS Code. And what I've done so far is like the prerequisite stuff. So all of these YAML files will be made public in our GitHub repo. And if you would go there now, you would see the entire end result of that stack. So what I've done is I've created a log group, I've created a cluster, and I've created the private DNS namespace. So I've created the cloud map itself, which is going to do a bunch of things for us. So the next step that I would do, actually step one, if you will, is, and this is obviously going to be the exact same stuff, is I'm going to create all the different services. So I'm going to create let me actually quickly show you if I go to my web browser. So what we'll be creating is this setup. So we're going to have a front-end service, we're going to have a user service, a bunch of other services, and as you can see, it's really a polyglot app. So we didn't go with like one programming language and went all in with that. And we really wanted to make sure that every developer on our team could choose the language that they love best. So which is why you see a bunch of Python, a bunch of JavaScript, a bunch of Golang. So that is what we're going to be creating. So let me actually run step 1. And what it's going to do is it's going to create the service for each and every of those components. So if I go back here, it will create, for example, for the user service, it will create the service here, but it will also create MongoDB pod. The thing with all of those containers is obviously security. I mean, who here does not care about security? Yeah, Sean, I really hope that you do, especially considering the fact that you own part of this app. So all of our containers that we have here are based on the golden images that Bitnami creates. Bitnami is now part of VMware, and one of the awesome things that they do, which is absolutely open source and free for everyone to use, which is why I like it, is they build containers that they keep up to date with the latest version of whatever it is that you might need. In my case, that's going to be Mongo or Redis. They have a bunch of Python containers, and they also make sure that it's tested. So when I get a container from them for, let's say, Mongo version 4 or 5 or whichever I need, I know that it's been tested, it works, and it contains only the packages that I need to run Mongo. So it's not going to have a ton of other stuff that might, blow up my attack vector. So right now that should be done, and we're pretty much ready to go to step 2. Oh, and that is creating the task definition. So I'm just going to walk through one of those task definitions so that you sort of see what all is in there, and I'm logging everything to the default AWS log service, which it doesn't do by default, so it's something that you have to turn on. It's a nice thing, and I've set the CPU limit and the memory limit. So CPU to like a quarter of a CPU. I've set the memory to 512 megabytes. And the reason I did that is because we created a Kubernetes manifest before, and I really wanted to make sure that everything was the same because I wanted to have a fair comparison. That makes sense, right? Good. Then I told it that it requires the compatibility with AWS Fargate. And that makes sure that when I start an instance of this task, that it is going to run it as a Fargate container as opposed to like just any Docker container on EC2. And I'm checking it so that every person that looks at this account can see that this is part of a version, whatever I said, the user that created it's going to be me, and stuff like that. And then at the end, I'm actually outputting the ARN for that task definition so that I can use that in other places as well. So if you go to CloudFormation, I should have a step 2 here, which in the outputs is going to tell me what that specific ARN is. So let's go with step 3. Step 3 is creating all the different security groups, and since we have a ton of them, because we have like 13 different containers, we create 13 different security groups to manage the ingress and egress of, so the inbound and outbound traffic of those containers. We set all the ports, so in this case, my payment service allows traffic on port 9000 from the order service, and since I did want to check everything running a jump pod, it's also going to allow it from one specific EC2 instance, because I did need one. So it's going to do that for every service. So I'm going to have a bunch of security groups in the end. So that means we're pretty much ready for step 4. And step 4 is actually creating that payment service. So if you go back to this part here, it is creating this service, which is in this case a relatively simple Node.js service, which takes credit card information, takes payment information, and tries to validate that the credit card details that you put in are actually a valid credit card. It isn't expired. It matches with whichever vendor you said was going to be the credit card vendor. So that it really matches up and we can securely process your payment. So what it does is it's actually going to look at launch type, setting that to Fargate. It's going to look at, which is actually kind of nice, it's going to look at the registry ARN, which is the task definition that we created. It's going to look at, and this is probably the most important thing to note, it's going to assign a public IP. The reason that it assigns a public IP is because that IP address is then published into AWS Cloud Map. So that is the part that takes care of the service discovery for me. So instead of having to know all the IP addresses or having to come up with some elaborate scheme on how I want to do that, I can just say, as soon as you come up, publish your IP address and your name into AWS Cloud Map. And from AWS Cloud Map, all of the other services that need to connect to you will just call you by your name. So if you would go into like the completed stack, which is available on our GitHub page, you would see things like this. So in this case, the user DB with a DNS record that has a 10-second time to live will register itself, and every time that someone needs to access our user DB, it can do that by the name user DB and whatever prefix or suffix you've given to it. So by now, all of the CloudFormation stack should be running. That one isn't, but that doesn't matter as much because we're going to switch over to the actual complete fitness shop, which now has like 44 resources. I did remember that number. So let me quickly show you, and I'll go back to PowerPoint for a second. Let me quickly show you how all of that looks like, because we just created a ton of different services, and this is the end result. I mean, I took this picture from CloudFormation. I just created, using the designer, created an image out of this. And this is relatively complex. I mean, I'm not sure about you, but I found this really difficult to understand. So the big question is, how can I monitor this? And there are a ton of solutions out there. And since we're at the VMware booth, I did want to talk slightly about one of the solutions that we have called Wavefront. So what I'm going to do is I'm going to open up Wavefront HQ in my browser. And one of the nice things that it does is it allows you to create dashboards using all sorts of things. And right now, all of this information is coming from AWS. It's coming from the containers itself so that I can monitor and see what is going on. So for example, I can see that in this graph, which measures the CPU utilization, that my catalog service over the past 5 minutes used about 17.2% of CPU. Which is great because that allows me to see whether or not I should increase or decrease or can decrease the settings, because that ultimately determines what I need to pay at the end of the day, or month in this case. The other nice thing about Wavefront, and let me actually go, I'll actually show you this, is that you can set a ton of conditions. And yes, I absolutely am going to copy paste this condition to create an alert. So what I'm going to do is I'm going to go over to alerts. And what it's going to do is it's going to allow me to say if this particular thing happens, like if the CPU utilization goes above a certain threshold, send me an alert, because I really need to know. If something goes down, if the number of services, I had like 9 services running, if that drops below a certain number, then apparently my pods are crashing, my services are going down. So I may need to do something about that. So in that case, I can just paste it in here. And it's actually showing me right now that on the screen that this is where it would have triggered. So I can visually see what's happening. So rather than sort of guessing that this was going to be the right thing, I can actually see that in this period here, this function would have triggered. And that meant that in this case, what I'm checking is the CPU utilization, that it's below 10% for a specific service. In that case, I might want to do something about that, because that either means that my front-end service, in this case, isn't used as much, so I might want to scale the number of pods down, or it might mean that it is actually totally down, and I need my SREs, my on-call team, to really make sure that it starts working again. Which to me, sorry. Yes. Absolutely, absolutely. So there are a bunch of things that you can do. So right here, I could send it to an email. I can send it to PagerDuty. The other thing is I can create alert targets here, which would actually trigger external systems. So those are definitely things that you can do. By the way, if you want to know more about how Wavefront works in detail, we actually have another booth over at the Venetian with a bunch of super experts on Wavefront, where they'll gladly go into detail exactly on that piece. So, as we sort of looked at this, let me go back to my favorite piece of the presentation. Let's talk about that million-dollar question. So we talked about this. What is it going to cost? What is it going to cost me to run the entire app with all the databases, with all the services, with all the cloud map stuff? What does it cost to run that for a month? Let me show you. So of all the services I use AWS Cloud Map. That's going to cost me about $4, which is not that much considering it's actually really good DNS. So for EC2, since we're only using security groups, that's not going to cost me anything, which is nice. Amazon CloudStrut Logs, since we're sort of in the startup phase of our Acme Fitness shop, I'm going to say that we just cap it at like 5 gigabytes of log data, so that's going to be free. AWS has a really nice free tier of stuff. So for Fargate, that's actually where the biggest amount of money is going to go to. That's going to cost me about $118 based on the fact that I have 13 services running. Those are the services including the databases and everything. And every service has 1/4 of a CPU and 512 MB of RAM. And then data traffic, 3 gigabytes. So first gigabyte's free. The other 2 are going to cost me like 9 cents. So for a grand total of $122 a month, I can run an entire fitness shop. Granted, we're still in startup phase. I can run an entire fitness shop on Fargate. Now, I have done the math on doing that on Kubernetes as well. And if we're actually going to publish a blog in probably in the near future, Sean, based on that, where we looked at the difference between doing that using a self-hosted version of Kubernetes, so we're running that on an EC2, versus this. And everyone that raised their hand saying that Fargate was going to be cheaper was absolutely right. The Kubernetes version of this would cost about double. And to me, that was actually very surprising. I mean, over the past few months, I've seen so many people say that serverless was always going to be more expensive, was never going to be more cost effective than having your own resources. And it turns out it is not the case. Granted, I've only looked at compute. There are a ton of other factors that come into your total cost of ownership. But at least for compute, it turns out Fargate is absolutely cheaper than running your own Kubernetes cluster. So with that, let me actually go back. Oh, I wasn't going to do that. So let me go quickly back to that first slide. If you want more information about all the cool stuff that we do, all the cool stuff that we write about, or if you want some links to all of the CloudFormation templates that I've shown, go check out cloudjourney.io, or if you have any questions to me or to any of the team, send us a note on cloudjourney.io on Twitter. Thank you very much.